That was perfect. Like, I started right as you clapped, so like it got your hand.
Okay, so we're starting. Graphing piecewise functions.
Someone told me I was late.
Were you telling me you haven't really done these before? Like, or you're not really good at them? Well, you're gonna really hate them now because
Oh, that's good to
thank
know.
you. All of the functions that I give you within this piecewise function,
Are not
you
gonna
know
be-
how to graph. Like this, you know how to graph. You know how to find the zeros, and it's like if the degree is even, you know, it goes. Both ends go up. If the degree is odd, it's 1 and 1. You know what I mean? And if you wanted to graph this, you would know, of course, that it's a basic shape, 1 over x, but it's moved to the left 2 and it's moved down 3, right? We'll go over that again in a second. But each graph you're going to know how to do. Now, it might have been something we started with, like a basic shape, or it could be one of the rational ones. We got to find the end behavior and the vertical asymptotes and all that. But the thing is, like, each function is going to only exist within a certain range of space. So this is like, if you can graph these, then you get what we've been doing for the last month. So, when you graph a piecewise function, there's a couple ways to go about it. First of all, realize this is a function, meaning it's going to always pass the vertical line test. So, let me start with this one.
I just. That one's so much easier.
Okay, this one's really easy. So this is probably a better place to start, and then let's move to the hard one. So these two functions, y equals 2x
Solid.
and y equals x squared, are easy to graph, right? Y equals 2x is a line with a y-intercept of 0, a slope of 2. So the line looks like this. Now it's really quiet. It's
We're trying to learn.
And y equals x squared is a parabola. It looks something like that. Well, if I have them both graphed together, it's not a function, right? Because I've got 2 on the same, so like it doesn't pass the vertical line test basically anywhere except at the origin, so it doesn't work. Well, I'm telling you that this graph splits at 5. So 1, 2, 3, 4, 5. So at x equals 5, 2 different things happen. First, when x is greater than 5, the line exists, so the line starts here. It's open. And it goes to the right because it exists when x is bigger than 5. So I could go through and erase the rest of the line. Do you know what I mean? Because the line only exists when x is bigger than 5. The parabola only exists when x is less than or equal to 5. So I can close this up, erase the right-hand side, and keep the left-hand side.
Wouldn't it be above?
Well, that's what I might have wrong. So I have to check myself because this might be not right. And I don't usually care about like how wide a parabola is or anything, but I have to draw them like with the right relation to each other. Where would this point be? If this is the line over at 5, what y value would I be at?
25.
10. Well, when this is over at 5, what y value would I be at?
25.
Okay, so my picture's totally screwed up. So what I can do to make this work, let me just erase the line. Let me scooch it down. Do this kind of thing with it. Show that this is 25, and I'll mark this as, what did I say, 10? Yeah.
But then that one can't start.
You feel like it's not a function?
Yeah.
It still is, because,
Even though those points line up.
I could use a ruler, but
Because one of them's.
every vertical line is only going to hit one point, because at 5, it's only going to go through this one that's solid, that's filled in. This one is empty. So there is no point here that's going to get hit twice by a vertical line. All of these are only going to hit once, and then when I'm here, That's why I can only have one of these as equal to, and not both. If it was both equal to, that's not a function, because the vertical line would pass this point and this point. But as long as one's open and one's closed, you're good. Is that okay? Okay, so that's really the easy one. There's just 2x and x squared. Oh, parabola line, easy. That one. Yeah.
That's why you gotta use pencil.
Use pencil, for sure. What?
This the drawing. Ridiculous.
Max, always a disruption. Just kidding.
I'm sorry.
Okay, so for this one, it splits up at 2. Okay, that's good to know. I would probably just go through and kind of graph this. And once I get to 2, I'll stop. I won't graph when x is bigger than 2. I'll just try to get what happens when x is less than 2. Or I'll graph the whole thing lightly and I'll erase the part I don't want. Do you know what I mean?
Use like a
So if I'm going to graph this, I have to stop and think. All right, well, this is split up for me. How am I supposed to graph that? Find the zeros. So this has zeros at 0, at -1, and at 3. Now, I understand this graph only exists when x is less than 2. So does the 0 at 3, do I actually need to make sure I show that? No. But it might be helpful to make sure I have the shape right, to leave it there and then erase it later. Because I want to make sure I know how many degrees is this? What's the highest degree?
3.
3, right? If I multiply it back out, it's 3. So I know I'm going to lift up to the right, down to the left, and I don't have any double roots, so everything's going to just connect. It's going to look like that. But I'm using pencil for a reason, because what I just graphed is too much. This is only supposed to happen when x is less than 2. So at my x value of 2, I'm supposed to stop. Now, that isn't the vertex, I don't think. The vertex should be halfway between 0 and 3, like 1.5. But I should know where this is. I should know this point is at 2 comma what? I should figure out the y value. So when I go graph the other one, I kind of know whether I should put it above or below or whatever. So what is the y value if x is 2? So plug 2 in. 2 times 3 is 6. So -6?
Yeah.
And then I'll erase it. Everything that was to the right, I'll erase. And it's an open circle, so I'll make sure I put it open. Is that okay? I'm not going to be all picky about whether this actually is on the way back up or if it's on the way down. It's fine. As long as it's in that loopy part, you're fine. Okay, now we gotta graph this. So hopefully you see it and it says basic shape to you. And the basic shape that it is 1 over x, which if you remember has asymptotes here and here and looks like that. But the asymptotes are changed. Where is the horizontal one moved to?
Down 3.
Down 3. Okay, we got a -3, so my horizontal one is down 3. I'm just going to really lightly put it in. And my vertical one is moved -2. So what's really annoying about this is that this graph is only going to exist when x is bigger than or equal to 2.
So it's like a line.
So it's really kind of annoying, but I know that I'm supposed to be here, and I'm supposed to be here. Should I even draw the left-hand one?
No.
Probably not. Okay, I'm not even going to draw that left-hand one.
Didn't you get rid of the asymptote?
I will in a second, yeah. The right-hand one's going to get drawn here, and it's going to come closer and closer and closer to the asymptote. Well, all I really care about is let's see where I am when I'm here. because I'm going to get here and whoops, closer and closer and closer and closer. It looks like a line, it's really not. God bless you. I don't know how to make it not look like a line without making my graph bigger or more stretched out vertically. But technically this is a curve. And I want to figure out where this point is. So 2 comma, let's see, 1 over 4, so 1/4 minus 3. God bless you. 1/4 minus 3, negative 2 3/4. So whatever, there's that point, and it's coming down, down, down. The asymptote, you can leave. The vertical one I'm definitely going to erase because there's nothing that needs to come up to it since I don't even have that graph. You can leave the horizontal one if you want. You could leave it just happening there since it doesn't happen on the other side. And there's your graph. This has no practical purpose whatsoever, other than making it really hard for you. It's just to kind of test your skills of graphing and see, like, do you really know what you're doing, or do you just know kind of how to graph each one separately and go from there? Want to do another one together?
No. I just don't want to do one at all.
No. Let's do one. Let's see.
God, you got a lot of homework.
I know.
Oh, that's a good idea. Okay, let's just.
I don't write down my homework every day. I don't write it down. Some days. Yeah. Friday, Thursday,
It's not like a piecewise in itself.
Yeah, no, I should.
Every day. You're so happy about it.
She's like, yeah.
Come on, it's not like things that you're even like.
I'll never have to use this in real life. Never, ever, never, never, ever.
Piecewise.
But like, why would I do it for your calculator stuff?
What? Piecewise.
I don't like that.
We need to say that 20 minutes after all of us are
What do you say?
She's not gonna
Me.
Nah.
I care.
Alright, the goal here is to make you like super graphers.
Or like
we should order
super,
t-shirts.
super hate
Can we?
graphing.
And have like some really crazy graph on the back?
Right? Got graphs?
Could we do it?
Yeah, I don't care.
I'm not gonna buy that thing.
Come on.
Unless it was like a
A little
cape.
bit of honors pre-calc super grapher t-shirt.
Right?
Unless it was a cape.
Dude, that's pretty
I'd
cool.
buy it.
And like it said got graphs on the front, and like you flipped it over your head, and then there was like a graph on the inside.
Awesome.
Just for math.
True.
Awesome.
And I'd pack it in my backpack and only wear it in math class.
And you could like fly into the class.
Yes.
This is sounding better though.
Right? Okay. 3 is where the graph splits. I know, this is what I do for fun. Sick. Okay.
Sick.
Alright. Absolute value of x plus 1 over x plus 1. You should know now, this should kind of start to jump out at you as something that's actually relatively easy. Because this is going to equal what when x is bigger than 1? Negative 1. 1. And what's going to equal when x is less than negative 1? Negative 1. Okay, this graph you want to start to remember always looks like this. Always is a horizontal piece and a horizontal piece. Open, open, going in either direction.
Wait,
It
they're
just
both open?
They're both open. Yeah.
They don't cross.
Oh, because of the x's.
Because the denominator is never going to allow you to plug in negative 1. And it just depends on where this is shifted. This time it's left 1 because negative 1 is what gives you that 0. So if I'm going to graph this at x equals negative 1, I'm switching from open this way to open and this way. Any questions on that graph? It's always that absolute value over its identical partner. Sometimes you've seen like a 5x here. That just really is pretty crazy. But you might see like a 2 here. that would mean these lines are up at 2 and down at -2 and horizontal.
Why
That's
is
all
it
it
the
comes to.
negative one though?
It's at -1 because -1 is what makes this 0, so that's where that split's going to happen.
Oh, okay.
Alright, now this graph only is valid up until we get to the x value of 3. So at 3 it's going to stop. It stops on an open hole because I don't have it equal to. Yeah, go ahead. So this is when x is less than 3. So this graph happens only up until here. So here I got to cut it off, erase the horizontal line, and it's an open hole because it's not equal to under 3. Now the second one, what kind of shape is that? It's a parabola. So let me just take the parabola out for a second. 2x squared. The easiest way to graph a parabola is to find the zeros and see if it factors. I don't know. I tried to make it so it didn't factor.
Yeah.
But I could always be wrong.
I don't think it does.
2x and x. Yeah, I'm never going to get a 6 out of that. So it doesn't factor. What's the next thing you would do? You could try a quadratic formula to find the zeros. But the square root of b squared minus 4ac. Oh, that will work. You can do quadratic formula. There's one other thing that the BC class reminded me of. When graphing a parabola, can't you just like find the vertex? Isn't there like a little formula for that? Isn't it b over 2a or
negative b
something?
over 2a.
Is it negative b over 2a?
Yeah.
I forgot about that.
I remind me.
We didn't have to complete the square.
It's negative 6.
Didn't I remind you of that?
What's that?
I thought I brought that up.
You did?
I think so.
You know, maybe you brought it up a few weeks ago and then completing the square I just forgot about it. Maybe?
I brought it up before we had started
Before
completing
we
the
did
square.
it,
Like I
yeah.
just asked, like, isn't there a way
Well,
to
that's
do
the x value, and then you have to plug it in to get the y.
Yeah, so like if it doesn't factor, quadratic formula is annoying too. Completing the square is really not necessary, is it? Oh, we got
I did
this.
that.
Bazinga.
Man, all that work for nothing.
Why do you need the vertex?
Because if we know where the vertex is,
Oh, then we can just do
and we know, say it opens up, then we know it's there.
Okay.
That's helpful. So negative b over 2a, so negative 6 over 2 times 2. So negative, 6/4, negative 3/2. So that's the x value. So vertex is at negative 3/2, comma, where's the y value? Oh, that's really annoying too. There's no non-annoying way.
Oh, but it just cancels. It reminds me.
And then you plug 3/2
Does
back in.
it? So negative 3/2 is going to be 9/4.
Times 2 is 18/4, and then 6 and negative 3 is negative 18/4, right?
So this will be, 18/4 minus 18/2.
Oh, that's
Wah,
true.
wah, wah. So it'd be minus 18.
This is so stressful.
That's
This is really annoying.
So it'd be minus.
This is worse.
Minus 18/4 plus 3.
Yeah, so negative 18/4
Which is like-
plus 3. Use a
which is
calculator
like
for
negative
that. Use
6/4.
So this is negative 4.5.
Why is it? Oh, never mind.
Why don't you just do negative 18? What's
Why don't you just like make it
Isn't
12
negative 18 divided by
fourths?
2 is 9?
Negative
Negative
6
9
fourths.
Yeah, I was doing negative
Is
18 divided by
negative
2
6,
is
so
like
negative
9
18
plus
fourths
3
minus
minus
6.
6, so it's 18 fourths minus 6.
Because 18 halves is
Yeah.
9.
I'm really cold.
So what's 18/4 minus 6?
I don't know.
How come it's minus 6?
Because
Yeah.
Because negative 18 halves
plus
is
negative
9.
9.
Okay.
And then
Plus
negative
3.
9 plus 3 is negative 6.
18/4.
Well, just do negative 18 plus 16. Plus 12, I mean. Is 6. Negative 6. 4.
Can we just quit?
That's what the answer is.
What's 18 minus 24?
Negative 6/4.
That's what I got.
That's what I've been saying this whole time.
Do it however you want. Goodness gracious.
That was worse.
But that doesn't
So
really
it's
matter.
negative 3/2, negative 3/2.
What possessed you to get up and straighten your hair?
So,
But that doesn't really matter in the long run because that's in the other side of the graph.
right.
Are you donating?
Oh my
It kind of gives you a
goodness.
starting place to go from. So like,
You
Negative
could've
1.5,
just plugged in
negative 1.5.
three and started from there.
Here's the vertex. All I want to find out is where's this.
Wait, question.
Yeah.
Could you have plugged in 3
Inquiry.
into the thing?
And notice a
and
problem
figured out
down
where
there.
it started?
Wow.
Why didn't we just do that?
Why didn't we just?
That would have been so much easier.
You see, it's good.
So
We're
annoying.
figuring it
No.
out together.
Are you done?
It's good. If you want to take 3 and you know it's a parabola opening up,
Can I be excused?
just plug 3 in. So 3, 9, 18 plus 18 is 36. 39?
39.
Mine's a little off scale.
What is like coming to right now?
It goes from 1 to 39.
Yeah, clearly.
39.
That was a pain
So like, could you just do that on a test? Like, could you just put like
Yes.
39?
Wow. That was so much work for nothing.
It's work for work's sake. It's like so
Oh, why did I just do
dumb.
that? Wait.
So we really didn't even need to figure out the vertex.
You didn't.
Do you have to? Do you have to make it like curved?
Nah, it's hard to rinse that high up. Yeah.
So this is our real life.
Okay, we are not going to do all of this.
It's so beautiful.
Once we're finished this, we're going to do domain, and then we're taking a test.
There's our final product.
I don't mean today.
Bye, Kaylee.
Oh, should I? Okay.
Oh,
See
Bye.
you later, alligator.